Introduction. For decades, our understanding of the universe has been split in two. We have precise rules for massive structures like galaxies and an entirely different set of rules for subatomic particles. But when these two frameworks are placed together, they contradict each other. We have followed the models left by the giants of physics, but even their most brilliant work remained incomplete. For all their insight, we were still left with gaps that these models couldn't bridge. To bridge these gaps, science began filling the universe with unproven forces and theoretical particles, assumptions about unseen realms that we have never actually measured. While the math behind these theories grew more complex, it moved further away from what we can actually see. We traded a measurable universe for a collection of mathematical exceptions. In his book, My Dear Universe, Nathaniel Faxon Cherier proposes a different path. He asks what happens if we strip away every unproven assumption and focus only on what is observable. The core hypothesis is that the cosmos operates within measurable boundaries, governed by a single, consistent process, rather than invisible theoretical padding. To find this unified reality, we will rebuild our understanding of physics using unfiltered observations. We'll begin at the furthest reaches of space and descend through the scales of reality to the smallest particles. Our journey begins at the maximum cosmic scale, the absolute edge of the observable universe. These little red dots, captured by the James Webb Space Telescope, are ancient galaxies formed 380 million years after the Big Bang. These cosmic fossils show gravity warping space and time, a direct result of observable mass, following general relativity without needing unseen forces. This data prompts a new set of questions. How did heavy elements emerge so quickly in these first galaxies, and what was the role of cosmic helium in shaping them? At this massive scale, the observations match the math. The large-scale universe behaves exactly as we see it, suggesting a singular rule is at work. Moving inward from the edge of space, we reach the macroscopic scale. This is the realm of classical mechanics, the physics of planetary orbits and the gas clouds that collapse to form stars. This scale was built on centuries of direct, unfiltered observation, starting with discoveries like Galileo's first telescopic views of Jupiter. At this scale, we refine our mathematical derivations to match the evidence we see, such as the uniform rate galaxies move apart and the predictable patterns of energy release. When we observe a planet's path or a collapsing star, we see the same consistency found at the cosmic edge. The macroscopic world operates on these measurable patterns, showing that the same physical laws are functioning across both scales. We now descend to the smallest scale, the microscopic quantum realm. For a long time, this subatomic world was thought to be an exception to the rules, governed by chaos and probability. Here, the unified field theory, or UFT, acts as the bridge. This theory was developed by refining our logic until the math aligned with what we actually observe at the subatomic level. The UFT shows quantum probability actually matches the causality we see in the macro world. The subatomic realm isn't a separate world with different rules, it's part of the same structure. This underlying structure brings gravity, electromagnetism, and nuclear forces into a single framework. Across 60 orders of magnitude, from the cosmic horizon to the smallest possible lengths, we are looking at the same process perceived from different viewpoints. When we view the universe through this lens, the contradictions between scales begin to fade. We are no longer looking at separate, broken domains, but 3 layers of the same physical process. This framework is built on an iterative cycle. We explore new connections in the math, then refine those theories until they match the empirical evidence of our observations. By prioritizing measurable reality, this approach provides a way to predict future discoveries using direct data rather than relying on theoretical assumptions about unseen fields. This is the starting point for a redefined view of physics. Over the next chapters, we will examine the specific theorems that reveal how this unified fabric governs the cosmos.